Welcome to qnawire.
Describe the geometry of each of the following molecules of ions and tell which hybrid orbitals are used by the central atom. All those elements belong to group 4A and 1s and 3p orbitals are involved in formation of those bonds. A, germanium tetrabromide. There are no lone electron pairs on germanium, so 4 bonds from germanium to bromine they point as far from each other as possible, which are the vertices of a tetrahedron. So geometry is tetrahedral. For this geometry, all orbitals are involved. So hybridization is sp3. B, carbon dioxide. There are no electron pairs on carbon. So 2 electron-rich area, they are pointing as far from each other as possible. So geometry is linear. Carbon is involved into formation of 2 pi bonds. And for each pi bond, it's contributing 1 p electron. So just 1 p electron is left for the formation of sigma bonds. And 1 s electron. So hybridization is sp. Carbonate. There are no electron pairs on carbon, and 3 electron-rich area point as far from each other as possible. So they are pointing at vertices of a planar triangle. So the geometry is trigonal, planar. Carbon is involved into the formation of a 1 pi bond and contributes 1 p electron for that. It means only 2 out of 3 p orbitals are involved into the formation of sigma bonds. 2 out of 3. So hybridization is sp2. D, tin Cl3 minus. There are 3 bonds and 1 lone pair pointing as far from each other as possible. So geometry is trigonal pyramidal, because if you put all atoms in the same plane, the distance between the shared pair and lone pair would be lower, which is in the trigonal pyramidal geometry. And all s and p orbitals are involved into the formation of sigma bonds. So the hybridization is again sp3.